Okay, hello everyone and welcome, and thanks for watching and listening. Today we're going to look at probability of multiple events. In other words, a couple events. What's the chance that a couple events are going to happen, not just one event? Today's essential question is, how does the relationship between two events affect their probability of occurring? There are three types of multiple events we're going to look at: dependent events, independent events, and mutually exclusive events. Guys, when the outcome of one event affects the outcome of a second event, the two events are called dependent events. If you look here, the probability of taking a blue ball twice in a row is affected by the first pick. If you pick a red ball the first time, well, the second pick, the chance of picking a blue one is 2 in 4. But if you pick a blue ball the first time, the chance of getting a blue ball the second time is 1 out of 4. So the first selection, the first event affects the second event. That's because we're not putting the ball back in between, all right, without replacement. Guys, when the outcome of one event does not affect the outcome of the second event, then the two events are called independent events, like rolling a dice or spinning a spinner. The outcome of the dice doesn't affect the outcome of the spinner in any way at all. They're independent events. And the spinner doesn't affect the rolling of the dice. Guys, if A and B are independent events, then the probability that they both happen, that A and B both happen, is simply the product of the probability that they each happen by themselves. Just multiply them together. All right, the probability of rolling a dice and getting a 3 and the probability of spinning the spinner and getting a blue, you just multiply them together. Guys, if two events cannot happen at the same time, they're called mutually exclusive events. All right, the probability that both A and B happen at the same time is 0. All right. But the probability that either one of them happens, we add up the probability that each one happens individually to find out the probability that A or B happens. Either one happens. Again, we cannot roll a 2 and a 3 on the same roll of the dice. So those events are mutually exclusive. So if we say, what's the probability of rolling a 2 or a 3, you just add up the probability of rolling a 3 and the probability of rolling a 2. Just add them together. All right, it's 1/3, about 33%, okay? Because you can get a 2 or a 3. Now, if A and B, if they're not mutually exclusive events, and we're looking for the probability that either event happens, you can add up the probabilities that each one happens individually, but then you have to subtract the probability that they both happen. Remember, these are not mutually exclusive, so they can both happen at the same time. When you add up the probability of A and the probability of B, you're including this middle part twice. So you have to subtract it out one more time. As an example, the probability of rolling an even number with the dice and rolling a number less than 3. All right, rolling an even number is 50-50. There's 3 out of 6, the 2, the 4, and the 6 are even numbers. And the probability of rolling a number less than 2 or less than 3, there are 2 ways. You can roll a 1 or a 2. Okay? So the probability of rolling A or B, of rolling an even number and a number less than 3 is about 17%. Because you can roll a 2. 2 is an even number and less than 3. All right? So the probability that either one of those events happening, all right, is 0.5 plus 0.33, but we have to subtract out, again, the 0.17 to get around 66%, which makes sense. Guys, and we'll look more at that one tomorrow. Examples like that tomorrow. All right, guys, a lot of today you're just going to classify things as dependent or independent or mutually exclusive. As an example, and I use this a couple times, you're going to pick a month from the year, like pick January or pick June or something like that. And then you're going to pick some random number between 1 and 20. All right, those, of course, are independent events. Your selection of the number has nothing to do with the selection of the month. All right, what about this one? I select a letter of the alphabet. And then, my second choice, I select one of the remaining letters in the alphabet. I don't replace the letter. All right, those are dependent events. Because the second selection of the letter in the alphabet depends on the first selection. It depends on which one you picked the first time. Guys, if Q and R are independent events, again, as another example, and you want to find out that they both happen, and you can just multiply them together. Multiply the individual probabilities together. That's the probability that they both happen, if they're independent events. All right, to ask, are these events mutually exclusive? All right, I have a standard deck of playing cards. I select a diamond, and then I select a club. You know, those are mutually exclusive, guys, because I cannot select a diamond and a club at the same time. Not in a regular deck of playing cards. However, if I had the same deck of playing cards, and I want to know what's the probability of selecting a heart, or the probability of selecting a queen, all right, those are not mutually exclusive, because I could select the queen of hearts. Both of those events could happen at the same time, so they're not mutually exclusive. Guys, if S and T are mutually exclusive events, in order to find the probability that either one of them happens, just add up the probability that each one happens individually. All right, if they're mutually exclusive, just add up the two probabilities. However, if they're not mutually exclusive, just like the example before, think of a bowl of fruit here. See how we have 2 green apples here? And we also have 1 green lime right there, okay? So the probability of choosing a green fruit or an apple, right, you have to be careful, because you could choose a green apple. They're not mutually exclusive. So you have the probability of choosing a green or an apple. There's the probability of choosing something green, which is there's 3 of them out of 10. The total is 10. The sample space is always the total on the bottom. Plus the probability of choosing an apple. Well, there's 5 apples here, so that's 5 out of 10. But then you have to subtract these 2 green apples, because the green apples are in the first part. They're part of the 5 out of 10. And the green apples are also part of the 3 out of 10, because they're green. So you have to subtract those 2 out again, because we're counting them twice. We end up with 6 out of 10, 60%, which makes sense, guys. Just look at this. How many of these are either green or an apple? Well, there's 2 green apples, 3 red apples, and then 1 green lime. That's 6. 6 out of 10 is 60%. Okay? All right, guys, that's it. There's a lot today, but don't worry. We're going to look at this again tomorrow. Guys, what do you do next? Just go ahead and complete the homework check in the purple folder. And these are today's 4 vocabulary words for the warm-up, okay? Thank you.